Interesting.
Okay, what we talked about yesterday, we talked about section 1, which is all about correlation, so R, the correlation coefficient. We talked about how to find it on your calculator. We talked about the work that I want you to show. And we talked about the fact that it's a quantitative assessment of the strength and direction of a linear relationship. Just to refresh your memory, how do you find R on the calculator?
You
go to stat, you go over to calc, you go all the way down to linear regression, which is number 8. And that will give you the value of A, the value of B, and then the value of R. And R squared also. Does that all ring a bell?
Yeah.
Yes.
Yeah. Starting next section. And then we start section 2. So I showed you how to calculate the least squares regression line with all the work that I wanted you to show, and then I showed you how to do it on the calculator also. Does all that ring a bell?
Yeah.
So yesterday we talked about this is the formula for y hat. We talked about this is the formula for B, this is the formula for A, and then we talked about all the numbers that I want you to plug in. Yes? And how I want you to find all of those. There's 3 different ways that you're going to be asked to calculate a least squares regression line. The first way is the way that I showed you yesterday. So I give you a data set, you plug all the numbers into your calculator, you find y bar and x bar and sy and sx and all that stuff. Yeah? That's what we did yesterday? Okay, a lot of times the AP test doesn't do that because if you put one number in the calculator wrong, it messes everything else up. So what the AP test likes to do is give you computer output. So there's also 2 different computer outputs that you need to be able to read. This is the one that's on page 8. So this is what's important. It gives you a line for x and a line for y. It tells you the means, and then it tells you the standard deviations. So because x is our first one, this 3 is x bar and the 7 is y bar. The 1.51 is xx, sx, and then the 5 is sy. And then Pearson's correlation, this is the value of R. So that's the other output that you need to be able to read. So just to refresh your memory, you would do y hat equals a plus bx. And then you would say, okay, b equals r times sy over sx. And you would fill in the numbers. So r is 0.949. The sy is 5. The sx is 1.581. So this would give you a b value of about 3. And then your a is y bar subtract b x bar. Your y bar is 7, the b is 3, your x bar is 3, so that would give you an a value of -2. This is the other output you have to be able to read. Most of the time, it's not actually going to say x and y though up here. It's going to say the like contextually what x and y stand for. So let's say the example we're doing, x is the number of hours studied. And let's say y is your exam score. So then up here, instead of x, it would say number of hours. Or it would say something like hours. And then for y, it would say score. And so you would need to read the question to know which one's x and which one's y. Got it? Okay, one thing I also want to point out to you. So in the case of yesterday, we got this equation, -2 plus 3x. You have to define your variables. So in this case, you would write x as the number of hours studied. Y hat, do you remember what the hat stands for? Predicted. You have to write that. So predicted exam score. If you do not write predicted, I'm going to count it as wrong. This is one way to write your equation. This is the way that I prefer. It's not the only way though. The other way that you can write your equation is actually put the context into the equation. So instead of writing y, you would write exam score. And then you put a hat over it to mean predicted. Equals -2 plus 3. And then instead of x, you would put number of hours. Please write both down so that you know both of them. I don't care which one you use, but you need to know both because you're going to see both of them. Okay, so the first way you need to be able to find the least squares regression line is if I give you the data set and you put it in your calculator and you have to find X bar and Y bar and all that stuff on your own. Second way is this type of computer output where I give you the information for X, the information for Y, and then you use the equation. Questions on those two before we look at the third one? Okay. So the third one is this output that you have on the next page. This is on page 9. Okay, this is the best output in my opinion because it gives you the regression equation. In this case, you just write down the equation. No calculations to show. Now, I'm going to make things harder on you. So what I'm going to do is I'm going to erase all of that so that you have to know how to use the rest of the output. So this output gives you the same information. So you have X and then you have that number there. That number is the coefficient on X. So 3X. And then you have this constant. And then you have -2. -2 is a constant, which means it doesn't have an X. So -2. Now, in stats, we want the constant first. So you would write -2 plus 3X. Again, most of the time, they're going to use context. So they're not going to write X. They're going to write number of hours. And then it'll say constant. So whatever is next to the X is the coefficient on X. Whatever's next to the constant doesn't have an X. You also have to be able to use this output. So these are 3 different types of output. You need to know all of them. Got it? Okay, next thing you got to be able to do. You have to be able to interpret slope and y-intercept. You did this last year. Well, not last year. You've done this throughout all of high school and middle school. But I, of course, I'm going to add my own little flair to it and make you do it my way instead. So, our slope is change in y over change in x. So the slope we got was 3/1. So our x stood for number of hours studied. So I'm going to say for each additional hour studied, the exam score is, here's where it's different, is predicted to increase by 3 points. It's not a guarantee. Just because you study another hour doesn't mean that you're going to get 3 points higher. You have to say predicted. This is just a general trend. It does not mean that every single person follows this trend. Got it? Okay. Idea that we're going to talk about at the end of the semester. Do you remember how the reason we take a sample mean is that we want to estimate the population mean? That's the whole idea. I don't know the population, so I'm going to select a sample and use that sample to predict the population. The same is true of this least squares regression line. The line we came up with is the line for one sample. We are using that as our estimate of the entire population. But do we recognize that that slope is going to change for each sample that I take? Not every sample is going to have the same slope. Not every sample is going to have the same y-intercept. So that's what this whole idea about a prediction is I have this trend that applies to my sample. Not everybody's going to follow it, and it might not be the correct equation. Y-intercept is the value of y when x is 0. So ours, I think, was 0, -2. So for 0 hours of studying, the exam score is predicted to be -2. Again, you have to say predicted. Now, in all reality, contextually, does that make sense? No. Majority of the time, your y-intercept is useless. A lot of times you're going to get a y-intercept that doesn't make sense. The slope is looked at way more often. Do you know why this y-intercept doesn't make sense? Yeah, like not contextually. There's a vocab word for it.
Extrapolation.
Yeah, extrapolation. Did you read about that, or you've heard it in another class before, or
Read about it.
you read about it? Okay. Yeah, this is really, really important. So, extrapolation says you get your least squares regression line. That regression line only works for the domain of the x's that were used to create it. So, if you look at page 8. Page 8 at the top says example data, and it gives you 5 different ordered pairs. What was the smallest x value there? 1. What was the highest x value? 5. So our least squares regression line only works when x is between 1 and 5. You would not want to use the equation outside of 1 and 5. That's called extrapolation. The issue with that is we know that our least squares regression line works between 1 and 5. We don't know if the same trend applies outside of 1 to 5. Does that make sense? Okay. Questions? Okay. So I could ask you, predict the score for a student who studied 10 hours. Okay, so this should seem pretty obvious. You're going to plug in 10. Plug in -2 plus 3 times 10, so that's 30 minus 2, so 28 points. What's the issue here?
Extrapolation.
This is extrapolation. So here's how you're going to see extrapolation in homework questions and quiz questions and test questions and stuff. It'll say, predict the score for a student who studied 10 hours. And then the question will say, is this a reliable prediction? So you're going to say, my prediction is that the student will get a score of 28. This prediction is not reliable because of extrapolation. My line should only be used for x values between 1 and 5.
So is that all I have to say, or do you have to use any contextual stuff?
You, of course, have to provide context. And I don't want, this is extrapolation, period. Like, you have to explain further what that means. So this is extrapolation because my line should be only used for x between 1 and 5. 10 is outside of that domain. Okay. I answered it. Is that clear? Yes? So in this case, you're going to have to write more than you think you need to. Okay. Do we think that we can do this ourselves? I think we need to practice the calculator stuff, though, because I don't think we're super awesome at that. So we're going to make up a data set right now. What are the 2 variables that we want to study? 2 numeric variables. You guys are actually doing this. So go to page 11. There's a data set there that has to do with ACT and low-income students, and we've looked at that data set at least 12 times. So we're going to use that page, but add a new data set in. What numeric variables do you guys want to study?
Wait.
Number of chickens on farm.
It's going to relate to you all. You all are my sample.
How about number of
Come on, what do we want to look at the relationship
height
between?
and our grade in the class.
Height, are you guys all comfortable telling me your grade in the class?
Yeah.
In the whole class? Probably
I
not.
don't know their heights either.
I mean, I'm pretty sure you know our grades.
Number of
That'd
opposite
be-
sex siblings.
And what else?
Height.
No.
and eye color? Or no, that's
No, that's not numeric.
You guys are horrible.
I don't care. Just give us an insight. I don't
What if we did number of strands of hair?
Shoe size.
Okay, I'm making up my own.
Don't be
I
bored.
just said that.
Oh no, but
I
that's
don't
gonna be
feel
too
comfortable talking about
late.
shoe size.
There's obviously correlation there.
Yeah, this is
There's
boring.
actually.
You guys couldn't come up with anything else, so I want to hear it.
Could, but we got
Number of
high.
opposite sex
Not gonna lie.
siblings.
No, you.
I don't feel
We
comfortable.
want to do something like the teardrops with the Mountain Dew stuff.
Yes.
Something
Okay, so we're gonna look at your women's shoe size and then height.
I don't know about.
So do we just
But
add
just
hair?
Stop.
You add.
If you're a guy, Whatever your shoe size is, you add 2. Ravi, what is your shoe size in women's?
Flipped it off. 13.
13. And how tall are you in inches?
That's a good question.
You don't know your own height?
An inch?
Probably like 5'8", 7.
5'8", so
I'm
68.
5'8". Wait, are you taller?
Oh, whatever. We're going with
Pretty
it.
sure I'm
It's
taller
fine.
than you.
I don't care.
He's 5'.
Abby, what is your shoe size?
8.
8. How tall are you in inches?
I'm 5.
5'4", so 64. Okay, Bobby, what is your shoe size in women's?
12.
12. And then what is your height?
67.
67. Allie, shoe size?
9.
9. Height?
5,
5'10". So 70? Yes.
15 and a half. 77.
Is there anybody shorter than Tony?
Size 6 and then 5'3".
Paul's 5'2".
Okay, we need one more. Andrew, shoe size?
12.
Okay, right now, I would like you to find the least squares regression line. Listen to this very carefully, though, because this is something that I did not tell you. The questions are going to be worded in such a way that you're given 2 variables, but they're not going to tell you what x and y are. Guys, stop putting this in your calculator, because I cannot stress enough how important this is. The question is going to say something like, find the equation of the line predicting height based off of shoe size. What am I saying? Predicting height based off of shoe size.
Height would be the y.
Height would be the y. So then your shoe size and women's size, this is x. You have 3 minutes to find the least squares regression line, including all of the work that I expect you to show.
Whoa.
That's 3.
I can do it in 3 minutes.
What? You're the teacher.
You've been teaching this.
I can do it
You
in
should
2.
be able to do this in 3 minutes.
I just made up these numbers. It's not like I could have done this
I'll do it in
No,
beforehand.
but you know how to do it.
Are you saying you don't?
Yeah, Paul. Not gonna work. Thanks, Paul.
Oh, you're great.
somebody verify that I got the right answer?
Yeah.
Yes. This is the work that I would expect to see. How did this go? Really well?
Yeah.
Actually, I did pretty well.
Okay. We got a correlation coefficient, an R value of 0.819. What does that mean? Strong.
Strong linear.
Strong and
Positive
linear.
linear.
Positive. Strong, positive linear relationship between your shoe size and women's sizing and your height in inches. My other class had a correlation coefficient of 0.97. So in that class though did shoe size in men's versus height in inches. Does that matter?
No.
No,
Why not?
units don't matter.
Units don't matter. Okay. What does this 1.156 mean? The slope. If I asked you to interpret it.
Use per woman's shoe size, like unit, I guess. It should go up, or it's predicted to go up by 1.156 inches.
Right. For every increase in women's shoe size by 1, the height is predicted to increase by 1.156 inches. Now, if I took Ronald McDonald and his
39.
39, I remembered it as 32, and his 39 size shoe,
Outlier.
That's in men's.
Would I
That's
predict-
41.
okay, so 41 in women's, would I predict his height using my least squares regression line?
Of course.
No.
No. Why not?
No.
Alex.
Because of extrapolation, you should only take shoe sizes between 6 and 15.
41 is outside that domain, so it could lead to an inaccurate prediction. Could our height be correct?
No.
Okay, it's possible, yes. But we don't know for sure.
8 feet tall, 9 feet.
Yeah.
Okay. Do we have any questions with this?
Yeah.
Nothing at all?
Actually,
Yeah.
would we have to show like us calculating that standard deviation of y and x or no?
No. No, if I ask you to find the least squares regression line, you don't need to show work for standard deviation or mean or R or anything like that. If I just asked you, find R, then I want you to show the work though. Okay?
Oh, I didn't show it for R.
No. That's what I just said.
Yeah.